better slow your Mustang down. Oh Lord, what I said now.
Okay, 3.1 is a review of sine, cosine, and tangent for right triangles. So chapter 3 in this course is actually about trigonometry with non-right angle triangles, but in order to do it well, we're going to review sine, cosine, and tangent for right triangles like we did last year. So we should be able to do a lot of this quickly. You did it very well last year. So a right triangle, of course, looks like this. It has a right triangle. This is the right triangle here. The way we show the right triangle is with that little square. And of course you know that the right triangle is how much? 90 degrees. The side across from a right triangle, this side here, has a special name. It's called the hypotenuse. And remember I showed you last year, if you don't know where the hypotenuse is, you could turn this square into an arrowhead and it points to the hypotenuse. But probably a better way to think of it is the hypotenuse is the longest side. And there's two other sides here. We can call those ones legs. So this is a leg and this is a leg. But when we're talking about right triangles, we can kind of do a better job than just calling them legs. We can be more specific. So we're going to look from one of the acute angles here. Acute is an angle less than 90 degrees. This angle is not acute because it is 90 degrees. It's a right angle. The acute angles are these two here. You're going to pick one to look from. Let's just look from this one. I'm going to put this symbol which is called theta, and that represents an angle we don't know. So if I look from this angle, we're going to name the sides. What's this side here? That's still the hypotenuse, right? It's still the longest side, so hypotenuse. What's this side here? Well, that side's kind of across from the angle, or you could say it's opposite from the angle. So that's your opposite. What's this one here? That one's right next to the angle, and a word for right next to is adjacent. So that's the adjacent side. That's how you name them all. Okay, now we're going to do the same thing. This is another right angle triangle. It's supposed to look exactly the same as this one, but we're not going to look from this acute angle. We're going to look from this acute angle here. So if we look from this angle, what do you call this side here? It's still the longest side. It's still the hypotenuse. What do you call this side? It was called opposite in this one. Is that opposite? No, it's not. It's right next to, so it is adjacent. And this one is now the opposite. It's across from the angle. So watch your opposite and adjacent. It changes depending on which angle you look from. By the way, some people wonder, well, why couldn't you call this one adjacent? Because that's also next to the angle. The reason you don't call that one adjacent is because it's the longest side. It's the hypotenuse. Okay, so there's only one adjacent. You can't call them both adjacent. And the hypotenuse is the hypotenuse. All right, now we're going to talk about ratios. Very important. People often forget about this. Please don't forget. These words, sine, cosine, and tangent, are just ratios. They're just comparisons of the lengths of these three sides, the opposite, the adjacent, and the hypotenuse. So there's three words. One, sine. Sine theta, in other words, the sine of some angle, is equal to the length of the opposite side divided by the length of the hypotenuse. The cosine of some angle is equal to the adjacent side length divided by the length of the hypotenuse, and tangent of some angle is equal to the opposite side length divided by the adjacent side length. We do expect you to memorize those, and luckily there's two easy ways to remember them. One is Sohcahtoa. I'm sure you remember that from last year. Some old hippie caught another hippie tripping on acid also works. You don't tell your parents about that one. And what this stands for is sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tan equals opposite over adjacent. So, just to make it crystal clear, this symbol right here, that theta, refers to an angle. That's saying the sine of some angle is equal to blah, 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 blah. Okay? And all of these other words, the opposites, hypotenuse, and adjacents, those have nothing to do with angles. Those are lengths of sides. That's how long the sides are. So all these words you could draw arrows to. I don't think I want to draw it to all of them, but all 6 of these, I guess I've done 5, I might as well do 6. There you go. All those words refer to length of sides. So just to give you a very quick sense of what I'm talking about, if we had a right triangle, a small little right triangle, and I have a 30-degree angle down here, and I measured this side divided by this side, which ratio is that? Well, that's the opposite divided by the hypotenuse. So I'm doing the sine ratio. And what I would find is that sine 30, in other words, the ratio of this side divided by this side, equals 1/2. I'll just tell you that's true, that sine 30 equals 1/2. Now, let's say I drew a humongous triangle, way bigger than this one, but you get the idea. It's much bigger than this one. And again, even though it's a right triangle just like this one, and even though it's bigger, this is still a 30-degree angle. If I was to measure this right here, the opposite side, would it be the same as this opposite side? No, obviously it's bigger. If I was to measure the hypotenuse, would it be the same as this hypotenuse? No, obviously it's bigger. But if I took this side and divided by this side, what would my answer be? What would you get? You would get 1/2. It doesn't matter how big the triangle is, or how small the triangle is. If it's a right triangle and you measure from the 30-degree angle, opposite over hypotenuse will always be 1/2. And if it wasn't 30 degrees, of course, if it was 32 degrees or something, it wouldn't be 1/2, it would be some other amount, which I actually don't know what it would be. But whatever it is in this one would be exactly the same in that one, etc., etc. Okay, that's a quick reminder from last year. Before we do anything else, though, you should pull a calculator out if you have one, and please set your calculator to degrees. And the way you'll know is it might have a DEG, a DEG, it might have a DRG, it might just have a D on your display somewhere. If you have a rad or an R, or if you have a grad or a G or a GR, this is going to give you all wrong answers. Okay, we'll use those next year, but for this year you want it to be set on degrees, so please do that. Okay, so we're going to figure out what sine 38 is. I can do this really quickly and easily. I go to my calculator and I put sine, gotta turn it on, sine 38 equals, and I get this. Now, I'll usually ask you to put it to 3 decimal places. So that'd be 0.615, but look, the next number is a 6. So does that round up to 5? Yes, it does. So you should get 0.616. So that's my answer, 0.616. But wait a minute. Just to make sure you're clear, what does this mean? This means if I had a right angle triangle and one of the angles was 38, I'll put it up here. One of the acute angles is 38. And this is the sine ratio. So that means opposite divided by hypotenuse. If I took this one, opposite, and divided by hypotenuse, what would I get? I would get 0.616. It doesn't matter how big, how small that triangle is. Okay, tan 27. So we just go to the calculator, clear tan 27 equals, and it equals 0.5095. Okay, now this is tricky here. If I went to 3 decimal places, 509, and there's a 5 after it, so is that 5 going to bump up this 9? Yes, it is. It's going to bump it up to 10. So what do you actually get? You get 0.510. I hope that makes sense. This 5 bumps the 9 up, becomes a 0, and you carry the 1. 0.510 is the answer. 0.510 is the answer. And the next one, cosine of 32.53. Okay, there's no more difficult. Cosine of 32.53 equals 0.8431. I look 3 decimal places. Is the 1 bump it up? No, it doesn't. So it just stays at 0.843. 0.843. Great. Now, what's the difference here? What's this question? It says sine theta equals 0.832. Okay, what this is asking is, if you have a right angle triangle, and the sine ratio, so we're looking from some angle, let's just say that one, and the sine ratio is 0.832. That means the opposite divided by the hypotenuse. I don't know how much this is, and I don't know how much this is, but when you divide them, you get 0.832. So which angle is it that has a sine ratio of 0.832? So here you're doing the opposite. You're not actually doing sine, you're doing inverse sine. The way you show that is you put inverse sine of 0.832. Or if you want to look really fancy, and they do this in university all the time, instead of doing this inverse sine, the sine -1, you put arc sine. It means exactly the same thing, of 0.832. And the way you do it in your calculator is we go to the calculator, and instead of just hitting sine, we're going to hit second sine, because you see in yellow there it says sine to the -1. There it is, sine to the -1 of 0.832. This means inverse sine. And what I get when I do that is 56.30. Okay, with angles I usually do it to 1 decimal place, so that'd be 56.3. 56.3. 70.3 degrees. Okay, next one. Cosine of some angle equals 0.443. How much is the angle? So I'm going to do, since I'm trying to find the angle, I'm going to do second or inverse or shift, some of you have, shift cosine of 0.443, and I get 63.7 as my answer. And this is degrees. Notice I put degrees on both of these because it's an angle. The last one, tan theta equals 14 over 5. Oh my gosh, I don't know what to do. It's a fraction. Well, there's two ways to do this. One way you could do it is you could actually figure out what that is as a decimal by going 14 divided by 5, and I get 2.8. So really, what I'm doing is inverse tan of 14 over 5, which is the same as 2.8, and then you could do it that way. Or your calculator is pretty smart. You can also just do it like this. You can put inverse tan of 14 divided by 5, because that's what 14 over 5 means, is 14 divided by 5 equals, and I get 70.3. Don't round it up because that's a 4 there, so 70.3 is my answer. The angle is equal to 70.3 degrees. By the way, a couple of things. One, some of your calculators you have to do it in the opposite order. Like for this one, sine 38, the way I did it is I put in sine 38, and for most good calculators that's the way you do it. But some of you have lousy calculators, sorry to be so rude, especially if you're using your iPhone, you're going to have to do 38 sine. Ugh. Okay, it's not going to work in this great calculator that I have here. The second thing I wanted to say is sometimes people get confused about whether I'm doing inverse sine or just sine, whether I'm doing inverse cosine or just cosine. So remember my wonderful memory device. Top 2 words to describe your teacher, that teacher being me. Those words are, Mr. Wadge is fit and hot, right? Don't you say this all the time to each other? Man, Mr. Wadge is so fit and so... No, I know that's creepy. Anyway, remember, if you have the angle, like you had in all these ones, I have the angle, I have the angle, I have the angle, you're only going to hit tan, sine, or cosine. But if you're finding the angle, like these ones, I didn't know the angle, then you're going to use inverse tan or sine or shift or second or whatever it is on your calculator. Okay, this should definitely be review. I'm hoping more than a few of you are rolling your eyes and going, hurry up, we know all this. Alright, we're going to get some lengths here. So, this is a right triangle. That's the first thing we want to check. So we can use sine, cos, and tan. This is the angle we're looking from, obviously. Don't look from this angle. We don't know it. So if I look from this angle, what's this side? That is opposite. And what's this side? That's the longest side. It's across from the right angle. This is the hypotenuse. Which one of our ratios has an hypotenuse and an opposite, or an opposite and hypotenuse? This one, sine. So we put sine, and if we know the angle, we write it down. And we do know the angle. Sine 57 equals the opposite, which is y, over the hypotenuse, which is 15. And the way I like to do it is I like to put it over 1 and cross multiply. So, remember how to cross multiply? I look at the two diagonals, and the one where I know both numbers, or I have amounts I can calculate, is that one. So I'm going to multiply those together. So y equals 15 times sine 57, and then you can divide by the number that's left over, which is just a 1. It's actually not going to make a difference. I'm not going to use my calculator anymore, so I'll invite you to try it yourself, but when you do that, you will get 12.6, and that's your answer. Okay, the next one, I think you need to add in some of these numbers. They're not on your sheet. So you have a 53 degrees here and a 17 centimeters there. So again, it's a right angle. I can use sine, cos, and tan because of that. I look from this angle this time. What's this side? That's opposite again. What's the y that we want to find out? That's the adjacent. Why do we not care about this side? And why did we not care about this side up here? Because that's not what the question's asking you. It's not asking you for that side. It's asking you for this side. And we don't know that side, so it's going to be useless. It's not going to help us in this question. These are the two sides that are going to help us. Okay, opposite and adjacent. Which one's that? Opposite and adjacent is tan. So I put tan 53, I always write the angle if I know it, equals opposite, which is 17, over adjacent, which is y. And I like to put it over 1. Notice there's two types of questions here. There's the type where the y is on the top, which is easy, you just multiply them together. And there's the one where there's a y on the bottom. Some of you learned what you do is you change the y and the tan 53, change their places together, or you can just do your cross multiplying again. These are the two numbers that you know both. So y is equal to 1 times 17, which is obviously 17, and then divide that answer by tan 53. If you do tan 53 divided by 17, you got it wrong, and lots of people do that. You have to do it in the right order. Multiply those together first, divide by tan 53. If you do that, you will get 12.8, and it tells us centimeters, so we can write centimeters this time. Okay, basically there's only 3 types of questions you really need to know, and everything else is just expands on that. These are 2 of the types, and the only thing different from that is whether the unknown's on the numerator or denominator position, and that's when you're finding a side. And the third type is when you're finding an angle. So that's what we're doing here, we're finding an angle. So obviously we're going to look from this angle. You never look from the right angle, and don't look from this angle because we don't care about this angle. This is the angle we care about. So you look from here. What's this side? This one's adjacent, and what's this one? Opposite. So which one's adjacent and opposite? Oh, it's the same as the one we just did. It's tan again. I should have done a cosine question. Darn it. So tan, if I know the angle, I write it down. But I don't know the angle. So I write tan theta equals, tan is opposite, which is 8, over adjacent, which is 15. Okay, what do I do next? Well, just to show you a second here, tan theta equals 8 over 15. Do you see that looks exactly like this question here? Like, it's not the same numbers, but you're just doing exactly the same thing. So all you have to do here is do your inverse tan. Because you're looking for an angle, you're going to do your inverse tan. You could start, if you want, by going 8 divided by 15 and see how much that is. 8 divided by 15 equals 0.533333. You don't need to do that. So theta is equal to inverse tan of 8 over 15 if you want to write it that way, or you could do 0.5333, do maybe 3 or 4 decimal places. When you do that, you will get the answer 28.1 degrees. And that's it. Okay, the last thing I want to say, and just let me fill that in, that this is 28.1 degrees. Often these questions will ask you to solve the triangle, and what that means is you need to find all the angles and all the sides. Well, you know this angle now. You've got this side already, it's 15. You've got this side already, it's 8. And you know this angle here, how much is that? 90 degrees. So there's 2 things you have left to find. Like this, I'm going to ask you to do this right now, solve this triangle. Even though it doesn't say it on the sheet, I'm going to ask you to solve the triangle. We still need to find this angle here. Let's call this triangle ABC. So you need to find angle B, and you also need to find this side here, which is AB. Which one of those 2 things is easier? Easier thing to do would be find angle B. You could get angle B really easily. How come? Because for every triangle, the 3 angles add up to 180 degrees. If you don't know that, you should write it down or something. Always, 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 in every triangle, whether it's a right angle triangle or not, the 3 angles add up to 180. So if you want to know how much this angle is, you could take the whole 180, subtract the 90, and also subtract the 28.1, and you'll get your answer. And if you do that, you will get 61.9 degrees. Okay, now we're left with getting this side here, this AB. People find this difficult, and the reason you find this difficult, I'll just write this in here, is because there's so many ways you could get this. Very, very quickly, I'll show you all the ways you could get this. You could look from this angle, the 28.1, and use that side. So that'd be opposite and hypotenuse. So that'd be sine 28.1 equals 8 over, let's call this m, okay, just so I don't have to write AB every time. You could look from that same side, angle, sorry, look from that same angle and use this side. So that'd be adjacent over hypotenuse. That's cosine. So you could do cos 28.1 equals 15 over m. You could look from the angle up here and use the 8. So that'd be adjacent and hypotenuse. It'd be cosine 61.9 equals 8 over m. You could look from that 61.9 and use this side. So that's opposite over hypotenuse. That's sine. Sine 61.9 equals 15 over m. These answers are all going to be the same. I promise you. If you try them, they'll all be the same. But there's a 5th way you could do it, and I think it's the best way of all, or the easiest way of all. What's the 5th way? If you know 2 sides of a right angle triangle, how can you always get the 3rd? Pythagorean theorem, a squared plus b squared equals c squared. So when you're doing Pythagorean, ask yourself, is the side we're trying to get the biggest side, or is it a smaller side? This is the biggest side, it's the hypotenuse. So you want to square both of these, and you want to add them or subtract them. You want to add them. So 15 squared plus 8 squared equals c squared if you want, since it's the hypotenuse, or you could say m, since I already called it m. 15 squared is 225, 8 squared is 64, and that still equals c squared. If you add those together, you get 289 equals c squared. Is that how much that side is? No way. There's no way it could be 8, 15, and 289. What's the last thing you do in every single one of these questions? You always take the square root. So if you take the square root of 289, it works out perfectly. You get 17 as your final answer. Okay, that's it. Everything you need to know about last year's trigonometry. Starting next day, we'll go on to new stuff.